rely on other service providers to provide access to their charging stations. So an e-mobility service provider, EMSP, offers EV charging services to the EV drivers. They provide access to the charge points within the network of this EMSP or other networks via e-roaming. So you can compare the current situation with this EV situation. Nowadays, you go to the petrol pump, you can fill in your petrol or diesel, whatever. You don't need to pre-book a particular slot. You just go there, get the tank filled, and move on. And similarly, the customers keep on coming. No need to book it, no need to pay it online, or you can say those kind of stuff. But with EVs, with charging stations, this e-mobility service provider, what we can do is we can pre-book our slots in the particular charging station that this is the time schedule for my vehicle. It will come here at this time and it will be charged. Payment can also be done online and everything can be accessed online, that how much it has got charged and whatever, all other related information. So uh, DIS Discom, it provides electrical connections to the charging station. So the CPO, it needs to coordinate with the Discom regarding the connection requirements as well as the communication layers in place to control the charging load based on the network condition. Obviously, for setting up a particular charging station, EV charging stations, I guess, are in Chandigarh itself as well, and it is now being set up in at various places. So these are certain things which need to be taken into consideration. One is, as we have seen, this charge point operators, which is a company operating a pool of charging points. Then it should be in connection with the EMSPs, e-mobility service providers, through a network. And they also need to coordinate with the Discom regarding the connection requirements, that how much is the load and everything. Okay, let's see the two types of charging, conductive and inductive charging. So conductive charging is a normal conventional mechanism. You have a charging socket, charging station or grid, and you are supplying the current, whether you are doing AC charging or DC fast charging. This is the arrangement shown here on the left hand side. But if you go on to see the right hand side, this is the inductive charging mechanism. Inductive charging, the phenomena of mutual induction or electromagnetic induction, that is via changing the magnetic flux, we can induce the EMF or the current in a particular device. Same way mechanism is inductive charge. The vehicle is standing over a platform where via inductive charging, via mutual induction, you can say the EMF or the voltage is getting induced and the battery is getting charged. Okay, so inductive charging mechanism, it is a new way of charging rather than the conventional way. Then some more details on this. Conductive charging uses direct contact between the EV connector and the charge inlet. You see over here in the diagram. Here you have the battery pack, onboard charger is there. Then you have this connected to a dedicated 240-volt circuit. 240 volts, suppose AC charging you are using. So conductive charging uses the direct contact is there between the EV connector and the charge inlet. But in case of inductive charging, there is no direct contact. The cable can be fed from a standard electrical outlet or a simple charging station. Now in this, there are two methods, as we have seen already in the CCS type 2 system. We have AC chargers and DC chargers. In the connectors, we have the pins for AC as well as DC. Next, inductive charging. In inductive charging, it uses the EM field, electromagnetic field, to transfer the energy between the two objects, between your 240-volt circuit and your battery. Okay, so this is used to transfer the energy between the two, and charging station is developed for this purpose as well. Dedicated will be there. Energy is transmitted via the inductive coupling mechanism to the electrical device, and this device or energy is used to charge the batteries. So you can see the difference in the two diagrams. There you were having a direct contact, direct charging slot and connector. Here via inductive coupling, you are trying to charge the device. Inductive chargers are used with induction coil to create an alternating EM field from a charging base. Simple mechanism. I hope so. All of you are aware of the term electromagnetic induction, Faraday's law of electromagnetic induction. Can anyone tell me the laws of electromagnetic induction? Anyone? Let me see. There are basically two laws for electromagnetic induction. Yes, anyone? No one? Electromagnetic induction. Yes, yes, Faraday's law. Can anyone explain me the two laws? Anyone can unmute and explain? It will be good for those who don't know. When a current carrying conductor is placed in a magnetic field, then a torque will be produced. Okay. But I'm talking about electromagnetic induction. Can you be a little bit more specific? This is okay. Okay, I'll explain. Magnetic field will interact with the electric circuit to produce EMF. Okay. Uh, Electromagnetic induction, basically, what does it state? A EMF or a current is induced in a circuit, closed path, as soon when the magnetic flux is the magnetic field lines crossing through that particular closed surface. They are changing. As soon as they are changing, either increasing or decreasing, till that time the magnetic flux is changed and the current will be induced. But as soon as the magnetic flux stops changing, then it will not produce any EMF. So the magnitude of induced EMF is equal to rate of change of magnetic flux. Very good. The formula is EMF is equal to minus of d dt of phi. If you take the magnitude, it is time rate of change of magnetic flux. So what you see, there is a negative sign as well. And that negative sign is your second law, that is Lenz's law. What does it state? The magnetic flux or the induced EMF that will be developed will always oppose its cause. Will always oppose its cause. So on this particular phenomena, this inductive charging, you can relate. The portable devices such as cars and trucks, they use the second induction coil to receive the EM field. And these EM fields are converted back into the electrical current in order to charge the battery of electric vehicle. Okay. Going next. Charging characteristics. So you might be aware of the charging profile. Even nowadays in the mobile phones, you can have a look at the charging profile, how the mobile phone is getting charged. So basic charging characteristics of a lithium ion is CCCV charging, constant current, constant voltage. First, battery is charged with the constant current and then the constant voltage is provided. So CC stands for constant current, CV stands for constant voltage. Constant current provides a faster mode of charging while the constant voltage is slower. You know, it gets charged from suppose 30 to 60% very, very fast. Okay. Although it takes a lot more of time, but more current is provided there. And then it moves to the kind of a saturation kind of a mode or the constant voltage kind of a mode. So you can have a look at the entire charging profile that will be shown here as well. Let me see. Mm, Yeah, this is the charging profile. So we'll come to this, don't worry. Okay. Then what are the standard requirements for doing this? The vehicle has to be on the standby mode. Only in few applications the vehicle can be charged while running. The charger module can either be on board or off board. It can be on-board charging or off-board charging. We'll see in the next slide. And according to the range of the AC network for charging, there are different levels of charging. What are those levels? Let us see those levels. So see here, mode of charging level 1, 2, 3, and level 3 DC. What are the Indian standards available? Type 1, Bharat AC001. These are the connectors, types of connectors that are available. Type 1, Type 2, GBT, and so on and so on. So mounting is on board for level 1, level 2, and level 3. For DC fast charging, it is off board. In that case, we need to bypass the onboard charger. So that's why for DC fast charging, it is off board. Placements where the EV's charging stations can be installed, it can be in residence, level 1, level 2, level 3 can be public private, and level 3 for fast charging, it can be on the highway. For fast charge, it will take less amount of time and will go. Now, what are the parameters? So phase is one phase, three phase in case of level 1. In level 2 also one phase and three phase. In level 3 it is three phase only and DC charging. There are no frequencies there. Okay. Then what is the voltage? The voltage is 120 to 240 volt and going up to 400 volt maximum. In DC it can go up to 550 to 700 volts. Then current is 16 amps in level 1, 32 amps in level 2, 65 in level 3, and it can go up to 100 and so on, 1250 amperes in level 3. So much high current. And similarly, the power rating as well will also increase. Charging time will be level 1 is, if you go with three phase, it is 2 to 3 hours. It is 1 to 2 hours in three phase in level 2, 20 to 30 minutes in three phase, and less than 20 minutes, approximately 15 minutes in case of DC fast charging. So this is the some parameters and levels of charging. Okay. Then next. Now, why don't we go with battery alone? The reason is due to frequent stop and go operation of EVs and hybrid vehicles, the discharging and charging profile is highly varied. So peak power of relatively short duration is required for acceleration and hill climbing. And energy involved in the acceleration and deacceleration transients is roughly 2/3 of the total. So these are some of the reasons mentioned why don't we go with the battery alone. Okay. And last, battery design has to carry out the trade-off among the specific energy and the specific power, and also the cycle life, how many cycles it can support. So these are some of the reasons which are, you can say, that's why EVs schemes are coming so much late in the market. But now industries are trying to overcome these disadvantages and some limitations. Okay, let's see this block diagram now. This is the complete block diagram. So here is your electric vehicle. It is coming to the electric vehicle service station, service provider. Here you have EV to EVSC communication to guarantee safe and secure supply of energy for battery charge. So one type of communication is over here. Then you have CMS, you have the server, EV to CMS communication to handle grid related parameters, user authorization, billing, and other related information related to charging. You can also access the data on the mobile phone because it is connected to cloud now. So it can be accessed on the mobile phone very easily. Okay. Then for locating nearest charging stations, reservations of the places, billing details, etc. So this is the entire, you can say, the structure or the block diagram involving communication, involving all the modules, EV, charging station, server, and mobile application. Okay. Then if we go in detail further, you see How it is done? You have a single phase supply, then you have EVSE, service equipment. You have the control device and the connector. This will be there in your charging station. The control device, the cord for emergency failure, etc., and connector you have. Then the electric vehicle, it will be moving to onboard charger. That onboard charger is discussed in detail in the below block diagram. Then it will going to battery, and battery will be running the motor and the motor control. Then AC charging station will have safety interlocks, AC supply, charge controller, and communication. Onboard circuit, constant voltage and constant current going to the battery. And battery is being managed by the BMS system, the entire communication, battery management system. And also you have in continuous communication with the power control unit or the power distribution box. So this block diagram is in detail of what actually is taking place when you are charging your vehicle. Then if instead of AC charging station, we have a DC charging station. In case of a DC charging station, the rectifier and the conversion will be carried out in the EVSC, in the electric or the charging station itself. Electric vehicle service equipment. You have AC supply, you give it to rectifier. Rectifier is the device used to convert AC into DC. Then you have a DC to DC converter, and then variable DC and safety interlocks, and then it will be supplied to your electric vehicle. So only difference between the two is here you have direct AC supply and you are using the rectifier on the electric vehicle. But here, in order to have fast DC charging, the conversion of AC to DC is taking place at the charging station itself. Okay, great. Next, onboard and offboard charger. What are the differences? Onboard, less energy transfer kilowatt. Problem of battery heating is not at all concerned. Weight on the electric vehicle obviously will be added. Slow charging, we can recharge at any place within the electrical outlet, even at our residence if we have the possibility for the charging. On the other hand, in offboard, higher transfer of energy, no flexibility to recharge in various places, complexities and higher cost, obviously. So this is the charging profile, as you can see. So there are various types of charging profile: constant voltage, constant current, constant voltage, and so on. So you can see over here in this pink color line, dotted line is showing you the voltage, how the voltage is increasing in the battery, and then it is attaining the constant voltage mode. Then is the constant current charge here. As you see, the current is denoted by this. The current is over here. And here in this level, the charge is getting. So main current requirement is within this phase. And then you have the constant voltage phase where the current is not at all, is not that much required because it has attained the constant voltage, and finally it will attain the complete charging. So you have a trickle charge, constant current charge, and constant voltage. Trickle is nothing but pre-charge, a kind of a transient kind where you are supplying it initially. So this is a kind of a charging profile that you can easily observe in the mobile phones as well, how the battery is getting charged. Okay, so next is okay. This is explained in more detail. So pre-charge, charging will start charging with a small amount of current. Battery capacity and voltage are very, very low. In CC charging, constant current charging, it is done at a set current value. You see here at a set current value, regulation current, it is being done. The resistance component will decrease as the battery voltage will increase, allowing the battery to be charged with a higher current. So the resistance decreases and current increases to a very fast value. You see the battery voltage level also rising up. Then we switch to constant voltage charging at the set voltage value. The specified charge voltage has been reached, but the battery voltage is low due to internal impedance. The charging current will decrease as the internal battery voltage is now increasing. And last is when the charging is getting completed. Okay. So In these 4 steps, the entire charging takes place. Okay. So this is some arrangement shown. The electronic circuitry involved in the onboard charger, the power transistors are used. Okay. So these are some of the links of e-bike chargers from Texas Instruments, Infineon 150 kV charger, and so on. And these are the standard connectors available as in North American standard, Japan, European standard, Chinese, and all other markets except European standards. So this is the type of connector available: type 1, type 2, DC CCS1, CCS2, and so on. You can see the connector types as per the standards. The connector that we have seen, this is the female connector and the male connector. Main pins are this L1, L2, L3 are the line for the 3-phase line. N is for neutral, and the center one is your protective earth, provides safety against shock and safety to the vehicle. DC plus, DC negative are the DC fast charging. Apart from this, you have CP and PP, that is proximity pilot and the control pilot. This pins tells the charging equipment, the type of cable it is connected to. Okay, as we have seen previously, the type of cable. And control pilot provides the bi-directional communication. This is the communication pin between the electric vehicle and the charging system. This will check the maximum amount of current that the EV is able to take at any one point in time. So for communication, we have this control pilot. Okay. So this, we have already seen this. So I'm not going to go into more detail of this. So let's stop this.